So, which one would you like me to do? Problem number 1 or number 2? 2? You got it. So problem number 2 off this worksheet, and this goes along exactly what we were talking about yesterday. So problem number 2, we have f of x is equal to 4 over x squared plus 2x. Okay, so first thing you want to do when you're dealing with these, until I teach you something called the quotient rule, is you want to move anything that has an exponent or a letter. You want to make sure it becomes a top number or a numerator. Okay, so I want to move this x squared, I want to move it up. If I move it up, that's going to change the original problem to this. Okay, any problems with that? That's just algebra 1 concept. Agree? All right, so then we're ready to go ahead and take the derivative. Bless you. We want to deal with x equals -1. So we'll label this find y value from original. So we're trying to figure out the y value of the point. Okay, that point will be where it's actually where it's called the point of tangency. That's the point that exists on the linear equation that is tangent there. So I'm going to take my equation and I'm going to replace the x with -1. So does everyone feel comfortable that this and this are now this and this? Does that make sense? I'll take silence as a yes, I hope. All right, so if you do the math, on bottom you're going to get 4 over 1 minus 2, which is 4 minus 2. So we get this right here. So this is the point of tangency, where this will be x1, this will be y1 once we plug back in. Okay, so you plug the x value into the original, and that finds you the y value of the point of tangency. So then you want to find the derivative and take the derivative of this portion. So that's going to give me -8x and then -1 from here. And that gives me -3 plus 2. Clean up the derivative, not having the negative exponents. The negative number's fine, but we'll move the x to the -3, we'll move it down. So go there, and that becomes our derivative. Okay, 8. All right, so then I want to take this -1 and I want to plug it in for the x value on the derivative. To the third plus 2 times -1. So this right here replaced the x right here. Oops, and I don't know why I have this, because that's not a -1. There's no x on that too. And then you just want to work out the math that takes place. So -1 times -1 times -1 is -1. So this becomes 8 over -1 plus 2, which becomes 8 plus 2. So that becomes 10. And that is our slope. Is that okay? Yo. Oh, you kidding? Let me get you this sheet of one of these. There you go. I'm working out problem number 2. This is similar to what we did yesterday. Just practice.
What the fuck?
All right, so once you get to that point, we can let's change our colors to, I don't know, let's give us a nice pink. So then I'm going to use the point slope equation from algebra 1. And we're going to plug in our x1, our y1, and our slope. to that, so I'm going to get y minus 2. It's minus 2 because it was negative, so when you plug in a positive, good morning. And then our slope is going to be 10. And x minus minus 1, that gives me an x plus 1. So friends, this is the linear equation represented in point slope form that would be tangent to the original graph at exactly at -1, 2. Okay? And that's how you jump through that entire problem. Okay? Will you guys try problem number 1? See if you can figure out how to go with it. Utilize the notes that we have to see if you can figure that out. And we'll go over problem number 1. I'll give you like 3 minutes to give it a good try. Deal? Find the y value. So how do I find the y value when I just am given this? What do I do? In order to find the y value, we don't have to do the derivative first. What we're do is we're going to just take the 2. So where those parentheses are is where x had been. I'm going to take this 2 and I'm going to replace it here and here. And that's going to give me -2 times 4 plus 8. So that's going to be -8 plus 8, which gives me 0. So my y value is at 0. So at 2, 0 on our graph is where our linear equation will cross or touch our original function if it was graphed. Okay? Then we want to find the derivative. Okay, so I'm going to bring this down front. So I get -2 times 2 x, and then I had -1 from this. And then the derivative of this is just plus 4, and the x goes away because it becomes x to the 0, which is 1. So our derivative is this. Okay, now I need to figure out the slope. In order to figure out the slope, I'm going to take this 2 and I'm going to replace it here. So that's going to give me -4. Oh, thank you very much. Gotcha. So -4 times 2 plus 4, which gives me -8 plus 4. So I find that I have a slope of my tangent line of -4. You good so far there? Then we're going to take these and we're going to plug into our point slope. So this is x1, this is y1. So I'm going to get y minus 0. Is it okay to have y minus 0? Sure. -4, and then x minus 2. So this is our linear equation that is tangent to our original graph at 2. Okay? Did you feel comfortable with that problem? Did you get it? Get it? Huh. All right. With that known, give number 3 a start. See if you can start on number 3. Doing it the same thing. See, if you get stuck, that's okay. I'll give you 2 minutes to get a start on number 3. All right, I'm going to start this. Kind of just walk through. This 4 goes here, goes here. Did I do that right? Did I do my math right? 3 over 4 plus 8. Yeah. Ooh, that's a nasty y value. What do you think? My math all right so far? Dude, we got a nasty fraction for the y value, don't we? 35 fourths, roughly 9, or 8.75. There's my slope. Ooh, that's a nasty slope. Dude, shame on Stirrup giving this stuff. So that is my tangent equation, and that's nasty. That will actually graph on Desmos, but that's nasty. Shame on Stirrup for giving stuff that gross. Question so far? You won't probably see one like with that nasty of a fraction. And I'll move the test to next week. Is that all right? Okay. This is much different math than you're used to, isn't it? All right. You guys ready for number 4? I will just walk through number 4. Number 4, you probably will never see anything. First thing I want you to change on number 4 is change it to x equals 8, not x equals 2, okay? So change that 2 to an 8. So what you want to do on this one is you want to get rid of the radical, so you're going to make it to the 1/3 power. 1/3 power is the third root. And then we want to find our y value. I'm going to take this 8, and I'm going to plug it in here and here. So I'm going to get third root of 8 plus 2 times 8. And then third root of 8 is, yeah, change it to 8. Change it to 8. It'll work. If we left it as 2, it's beyond ugly. And you guys might go outside and kick a puppy if I left it that way. Third root of 8. Anyone know what the third root of 8 is? It's just 2. So I get 2 plus 16, which is 18. So there's my x1 and my y1. And then the derivative, let's see, it's going to be 1/3 x. And then I'm going to subtract 3 over 3 because 3 over 3 is the same thing as 1. So I get to the negative 2/3 power plus 2. Clean up the derivative a little bit. So let's move that negative exponent down. And you can clean it up even a little bit more. And this is going to be the same thing as the third root of x squared plus 2. So then I'm going to take this 8 and I'm going to plug it in right here. I'm going to get 1 over 3 third root of 8 to the second power plus 2. All right, if we do the math right, let's see. So I can do the third root of 8 and then square it, or I could square 8 and then take the third root of 64. Both the same answer. So the third root of 8 is equal to 2. If we square that, that gives me 4. Or if I did the third root of 8 squared, which is 64, that's also equal to 4. So we find that we get 4 here. So I'm going to get 1/12 plus 2, which is 1/12 plus 24 over 2, or 24 over 12. So I get a slope of 25/12. So up 25, right 12. Yeesh. So then I plug into this. So I get y minus 18 equals 25/12 x minus 8. Oh my goodness. So I will more than likely not give you anything quite that ugly. You might have one that's a third root that you have to convert, but hopefully I made the test to where you'll come out to nice numbers. But that is basically how you find the derivative, points, tangency, things like that. If you would, tomorrow we're going to work on the review, go over the review, because some of the stuff we did before break, so I got to make sure to go over that. Friday we will do fair division, which is a state division. And that's the day I'm getting observed, so make me look pretty if you don't mind. And I'm not the guy who shows up in shirt tie on these. Cool? Everyone all right? A-okay?